Morning, everybody, and welcome to our webinar on slurry, getting the best out of your slurry. My name is Francis Quigley, and I'm joined today by Mark Plunkett, our soils and plant nutrition specialist, Patrick Kavanagh from Kildalton College, Richie White, contractor based in Vantage in County Tipperary, Kendrick Hull from Vantage Ireland. Just to let you know, we have a Q&A item there just on the bottom. So if you have any questions or anything, you just type them into the Q&A section there on the bottom of the screen, and we'll try and answer all the questions at the end of the session. Just to start off today, I suppose, we're just trying to look at the value of the slurry and getting the best use out of your slurry this year. And I suppose with the high prices for chemical fertilizer this year, it's I suppose it's never been more in people's minds how we get the best use out of our slurry, and hopefully from today's session we'll be able to give you some useful ways of maximizing the value out of the slurry that you have and applying it in the best locations. To kick off today's session, my colleague Mark Plunkett is going to give us a session just to take us through the nutrient value of the slurry, and I suppose how we can decide on the rate we need to use, and I suppose just the advantages of using some of the low emission equipment. I'll hand over to you there, so Mark.
Thanks, Francis. Good morning, everybody. Yes, this morning I am going to focus very much on the product, as in the cattle slurry, and later then we look at the technology and how it has changed over the last number of years. Most definitely, cattle slurry is a very, very valuable product. Fertilizer prices have taken a massive increase. Nitrogen has gone threefold, and P's and K's have doubled in price. Like, for example, if someone spent, say, 10,000 euros on fertilizer in 2021, in 2022 that same fertilizer would cost 27,000. So there's a 2.7 increase, price fold increase in fertilizers in 2022. And I believe that cattle slurry will be a very, very important source of on-farm nutrients to cushion the effects of those recent price increases. Also, on the Irish landscape, the low emission slurry spreading technology has increased. There is a lot more trailing shoes, a lot more band spreaders out there, and that technology brings many benefits at the current time, especially in terms of managing fertilizer costs and also meeting some of our environmental targets around ammonia, greenhouse gas emissions, and water quality. The trailing shoe, one of the big benefits that it brings is that it reduces the losses of nitrogen as ammonium at time of application, and it results in an increase in the recovery of nitrogen, thus reducing the amount of chemical or bag fertilizer that we have to bring onto our farms to fertilize our grasslands and other crops. There is a lot of work and a lot of research done in this area over the last 10 years in Teagasc, and this is a proven technology that it works and it delivers both environmental and production gains to Irish farmers. The low emission spreading technology is the #1 technology to reduce ammonia emissions. Like, for example, it will reduce our emissions by 60% in the years ahead where this technology is adopted. Another big advantage of low emission slurry spreading is the precision application. It's a bit like placing fertilizer for a cereal crop, and this was, I suppose, one of the big drivers of change on the continent, that farmers, when the reason they moved from splash plates to trailing shoes was the more even distribution of the nutrients across the spread width. It also brings the advantage of spreading the heavier grass covers, reducing grass sward contamination, and a quicker return of livestock to grazing our pastures. It also allows a wider window of application for slurry here in Ireland, and giving us better soil conditions, to protect the quality of our soils where this technology is used. Okay, so a number of questions. So again, in order to utilize the nutrients more efficiently from the slurry, the first question I would ask is, what is the fertilizer value of that slurry? A bit like buying a ton of fertilizer, is it 18, 6, 12 or 10, 10, 20? Now, the nutrient value of slurry can be quite variable. And again, it's very much driven by the amount of water in the slurry. Is it a covered tank, an open tank? Is there parlour washings? Is there is there yard washings or scrapings going into that tank? And it all will have an impact on the quality or the nutrient value of that slurry. Our standard slurry there is a 6%, good quality slurry, and it contains 9 units of nitrogen, 5 units of phosphorus, and 32 units of potassium. And as the dry matter decreases, as you go back to say at 2%, again, it's a more dilute slurry. It contains 4 units of nitrogen, 2 units of P, and 13 units of potassium. Dilution has a benefit in that it actually improves the efficiency of the nitrogen in that the slurry moves more quicker into the ground. The next question we should ask ourselves when spreading slurry is, where on the farm should this slurry be spread? And again, if we look at the nutrient profile for cattle slurry, 80% of the nutrients is actually in the P and K, 20% is in the nitrogen. So it's very important to have a plan as regards where the slurry is going to go based on soil analysis and target slurry to the low index fields. That is the place in the farm that will get full benefit from the N, P and K in that slurry, and especially the P and K in meeting the P and K requirements for high demanding crops such as grass, silage, or maize. Like slurry is a very well balanced fertilizer for our silage fields. And this is the place where we can, reduce the impact of high fertilizer prices in 2022. The next question, and a very, very important one, the P and K is relatively stable regardless of the time of application, but to maximize the nitrogen, it's very, very important that we apply the slurry at the right time of the year, and we delay that application until the conditions are right. The conditions that we're looking for, soil temperatures must be above 5.5 degrees. We're looking for good field conditions in terms of soil trafficability. So again, a positive soil moisture deficit. Also a good weekly forecast, and also good grass growth rates. In terms of where do we get this information? So Met Éireann, or in terms of soil temperatures, in Moorepark, we predict grass growth rates on a weekly basis, and this is the soil temperature prediction from Met Éireann data coming from Moorepark. And you can see soil temperatures are currently, for the majority of the country, somewhere around 3-4 degrees. So again, insufficient for grass growth. Also soil moisture deficits. Again, this is from the Met Éireann website, so soil trafficability. And again, our soils are saturated. There's a minus 10 mil there as we speak. The forecast for the week is actually quite good. So you can see very little rain forecast for the week ahead. And also coming from Moorepark in terms of the grass growth model, you can see grass growth rates are actually quite low, 3 or 4 kilograms of dry matter per hectare per day. The break-even ratio has increased in terms of the payback. For every kilogram of nitrogen, you need in the past 4 or 5 kilograms of grass dry matter paid for a kilogram of nitrogen. With the increasing costs of nitrogen fertilizers especially, that has now gone to 10 or 12 kilograms of grass growth to pay for every kilogram of nitrogen. The other, I suppose, big way of improving the nitrogen recovery, number one, is the technology. So again, where we move from splash plate to trailing shoe, we can recover an additional 3 units of nitrogen. So again, we have 6 units for the splash plate in the spring, and where we move to the likes of the trailing shoe, we can get 9 units. And the other one is the timing. So again, if we can spread more slurry in the springtime as opposed to the summer, like summer applied nitrogen with a splash plate is only 3 units per 1,000 gallons. So by changing the method in terms of the application technique from splash plate to trailing shoe, we can get an extra 3 units per 1,000 gallons, and then moving the timing, spreading more slurry in the spring, we can get another 3 units per 1,000 gallons. So that's a significant amount of nitrogen that we can retain or capture to grow grass and reduce our farm fertilizer requirements. What rate to apply then? So again, this is very much linked back to slurry quality. So I would strongly recommend that you have a plan and you keep enough good quality cattle slurry for the silage fields. Like if we take 3,000 gallons of good quality cattle slurry, it will supply the majority of our P's and K's and approximately 25 to 30% of the nitrogen for that silage crop. Where dilute slurries are available, they're very suitable for grazing ground. They have a lower amount of nitrogen and also a lower amount of P and K. And also key information there is the soil test results and crop requirements. So we target the majority of our slurries to grass silage crops or maize crops. In terms of slurry analysis, So we can to get a better handle on the quality of the slurry or its NPK value, we would strongly recommend that you test your slurry. So you can send the sample to the laboratory, which will cost between 50 to 80 euros. It's important to get a good sample. So, make sure that when you're getting a sample that it's safe in terms of getting that sample. And also the best time to sample is January to March. So we recommend when slurry is agitated to take out slurry with your slurry tanker and sample then from a gate valve on the slurry tanker. And again, when you're emptying tanks, you could take a number of samples in a bucket, mix them up, and then subsample that bucket of slurry. And the lab generally requires somewhere in the region of a half a litre to a litre of slurry for analysis. And again, very, very important to post that sample on the same day as when the slurry was taken. In terms of the analysis, so again, I would recommend that you get the dry matter done, the nitrogen, the phosphorus, and the potassium. In terms of the units that I would request kilograms of nutrient per 1,000 kilos or per ton or per cubic meter. So that's the easiest way when it comes then to converting it into the available NP and K. So in this example here, I have a worked example. So the nitrogen is 2.4 kilos per ton or per cubic meter. So first you must, this is total nitrogen. So 2.4 by the availability, which is 40%, divided by 100, it gives us approximately a kilogram of nitrogen per cubic meter, or 0.96 kilograms of available nitrogen per cubic meter. To bring it to units per 1,000 gallons, then multiply 0.96 by 9.08, and that gives us 9 units of available nitrogen per 1,000 gallons. For the P and the K, it's a little bit more straightforward. Again, you're taking the laboratory value, 0.56 kilograms per 1,000 kilos, multiplying it by the conversion factor, 9.08, and that gives you 5 units of P and 34 units of potassium. Alternatively, you can purchase a slurry hydrometer. They cost somewhere in the region of 50, 60 euros. So this is a glass piece of equipment. It measures the slurry dry matter. So you drop so instead of sending the sample to the laboratory, you can drop the slurry hydrometer into your bucket of slurry, and it measures the dry matter. And this can be linked back then to the nutrient content in terms of the NPK. They're the suppliers of slurry hydrometers. These are 2 suppliers in the UK, and they will post you over a slurry hydrometer if you make contact with them. The details there are available on screen, and we'll also make them available after the webinar. So Francis, in summary, we'd strongly recommend that you test your slurry to determine the NPK value of that slurry. Low emission slurry spreading technology brings many benefits, and especially in terms of recovering more nitrogen from the slurry. To maximize the utilization of the nutrients in that slurry, it's very, very important to check field conditions at time of application. So again, we should only spread fertilizer on a day that we'd actually spread bag fertilizer. We need good growing conditions to maximize the nutrients in that slurry. Also very, very important to match the application rate based on soil and crop requirements and the time of the year. And most importantly, have a plan for your slurry and aim to apply as much slurry as possible in the springtime. Francis, can you play we have a short video there in terms of the slurry hydrometer?
Yeah, I can, Mark, absolutely, yeah. Just to remind people there that we do have a question and answers section there. If you want to put any questions into that, feel free to put them in there. And we'll answer them all when we come to the end.
Today I'm going to show you how to use the slurry hydrometer. It's a device which is used to measure the dry matter content of the slurry, and we use that as an indicator of the nutrient content of your slurry before you spread it on your grassland. It's a huge advantage to know this information. We have some typical values for slurry content across farms, but the actual slurry value, the nutrient value, can vary a lot between farms. So this is a great device that we can use that'll give us a true value for our slurry before we spread it out. Our slurry hydrometer, I've been kept in this plastic case here to mind it. It's a glass device. It's very simple to use. It has a mark on it to measure the dry matter content. And it's as simple as just dropping it into our sample of slurry that we've collected here It's important to collect the representative slurry from either a slurry tank or from your slurry spreader. And it's as simple as dropping it in. We'll drop it to about the 7% mark. Wherever it'll settle, it'll only take a minute or two. We take that value, so 5, 6, 7, whatever the dry matter percentage is, and we look at our nutrient value given the dry matter percentage. And we have that in our Teagasc Green Book. So now I'll drop it in. After a minute, we can use the macro and nutrient advice book for indicating the nutrient content based on the dry matter of our slurry. At the moment, it's at 7%, and that can give us an NPK value of up to 8,530 based on this dry matter sample that we've taken. Key message is that it's a big advantage for the farmer to know exactly how much nutrient is in his slurry, so that when he does apply it to his fields, it's captured in the grass and we lose less of it towards the waterways.
Okay, hopefully was everybody able to see that video? They were okay? You're on mute there, Mark, sorry. Yeah. Mark, I suppose another thing, you were talking about, trying to hit that silage ground there. I suppose, by using the low emission and slurry spread in particular, like the trail and shoe, it gives us a better opportunity to use that slurry, maybe even a heavier cover. So that,
Absolutely, Francis. Yeah, especially the trailing shoe, you're putting the slurry directly onto the grass, you're parting the grass. So absolutely, it definitely does, yeah.
So I suppose allows us to wait maybe for those temperatures to come up.
Yeah, that is very true. Yeah, it gives you a wider window of application.
Yeah. Okay, so just on the testing of the slurry, you mentioned sending the samples off to the lab. Where are those labs, or where could people find out about those labs?
Any of the private labs that are testing soils, will test slurry. So we can put a list together and we can make it available after the call. But any of the private soil testing labs will test slurry.
Yeah, and we'll have a list of those.
Yes.
Contact details we'll put them up on the Teagasc public website. Yeah, that's great. Okay. I was just going to do a little bit on the calibration of the slurry tank. So just getting the calibration rates, and we've developed a tool for calibrating your slurry tank, and just to ensure that you're actually putting out the application rates, or the desired application rates. So it's basically it's a phone based tool. Well, it's online, but it'll work on your mobile phone. If you just do a search on even any search engine just for Teagasc machinery calculators, you'll find the slurry calibration tool. And I just have we have a short video here just to show you how that tool works. And I'll just share that now. Okay, so we're just going to take a look at the slurry calibration tool here. So once you open the link, it'll take you through to the form here on the page like this. The calculator uses 4 sliders. You can see there's one for the tank size, there's one for the working width, there's one for the time to empty, and there's one for the target application rate. And the bottom then is your forward speed, and you can see in bold there the forward speed, and this will change then depending on the settings above. There's also at the bottom just some useful conversion rates if you want to convert from gallons to the acre to meter cube per hectare. The first task that we need to do is we need to calculate or time how long it takes to empty one load of slurry. So the first load of slurry, you go out to spread, just time and see how long it takes to empty that load, and all of our calculations then will be worked around based on that. So let's say it takes us 4.5 minutes. We can just move this slider over to 4.5 minutes, and that's our time to empty. Okay. The next thing we need to adjust then is our tank size.
So currently it's at 2,500 gallons. So let's say we have a 2,000 gallon tanker. We'll just pull that back to 2,000 gallons. The next thing we're going to adjust is the working width. The working width, if it's a dribble bar or trailing shoe that you're using, it'll obviously be the width of the dribble bar. If you're using a splash plate or some other similar, like a masher or anything like that, just measure how far apart you're driving. So from one bout to the next. So measure from the center of one bout to the center of the next bout, and that'll give you your working width. So in our case, it's at 7.5 meters, and we have a 7.5 meter dribble bar. So that's okay. We can leave it as it is. The last thing then we need to set is our target application rate. So currently it's 2,500 gallons per acre, and it's telling me our forward speed would be 5.8 kilometers per hour. Let's say we want to bring that down to 1,500. So we just bring the slider across to 1,500, and then our forward speed would need to increase to 9.6 kilometers per hour. So that'll give us, that's our settings for our forward speed. So I suppose that's the only thing that we can, our forward speed is the only thing that we can adjust. The other settings will all be, just need to be measured and checked for your particular tank. Another thing that I suppose, might be useful, if I just drag this all the way to the bottom, I'm on an iPhone here at the minute. When I drag all the way down to the bottom and let go, you'll see this white band comes up on the bottom of the screen. In the center of that there's a box with an arrow pointing up the way. If I click on that box and then just drag down to the bottom of the page, there's a number of items here, but third up from the bottom is add to home screen, and you can see there's a plus sign inside the box beside that. So if I just click on that add to home screen, it'll pop up here. I can rename it to Slurry calibration tool, or I can change that just to Slurry calibration if I want. The icon is the pencil with the orange box around it. If I click add, that's going to add that to my home screen. So you can see now here on my home screen, down here in the bottom left-hand side, I have Slurry calibration tool after popping up on my screen. So now anytime I want to use that, I can just come across, find this page, click on that guy, and it will open up that web page. Now it's not an app as such, it's actually only a link to a web page, so you will need internet access. So to your 3G or 4G access to use it out in the field, but it just means that you can adjust those settings each time. And again, look, different slurry might flow differently through the machine. So if you have very watery slurry versus a thicker slurry, your time to empty might change, but by and large, it won't change hugely. So again, once you've recorded that, put in your information there, and you'll get your forward speed, and that's how you calibrate your slurry tank.
Okay, so folks, as mentioned, look, that tool is available. It's on the Teagasc website. If you just do a search, I'd say on any search engine, just for Teagasc machinery calculators or Teagasc slurry calibration, it'll take you through to that page, and you'll be able to find that calculator. And say it works for any machine and any type of applicator on the back. It doesn't matter whether you have a trail and shoe, a dribble bar, a splash plate, any type of system that you're using, you'll be able to calibrate it using that tool. Now, what you are doing is just to bear in mind, it's that first load. You're recording the time to empty that first load. Now, it's the length of time that the lollipop is open for. So if you're in a small field and you've a lot of headlands, you would need to be pausing your timer every time you're turning off the lollipop on the headlands. Whereas, if you're in a big open field, you're just spreading without having to close the lollipop at all, and just be that length of time. So just to record that time in the first instance. Next, we're going to go to Kildalton, where Patrick Kavanagh is actually going to take us through, just to take a look at some of the differences between the low emission equipment, and just to give us a better understanding of how they vary from machine to machine. So we'll hand over to you there now, Patrick, if that's okay.
Okay, so when it comes to low emission slurry spreading, you have a couple of different options. As you can see behind me here, we've dribble bar, trade and shoe, and just on the model here, we have a disc injector, a shallow disc injector. When it comes to the Irish market, the dribble bar and trade and shoe would tend to be the most popular. They just tend to suit the Irish conditions the best. Starting with the dribble bar here, I suppose the main difference between your dribble bar and a trade and shoe is your dribble bar will apply the slurry to the top of the grass. Your trade and shoe is applying your slurry to the soil. It's parting the grass via this steel tip here, the spring-loaded system here, that's actually going to part the grass and apply the slurry on top of the soil. Your dribble bar is going to apply your slurry on top of the grass, which in turn will smear the grass a certain amount, contaminate the grass. But alternatively, the dribble bar is a cheaper option. It tends to be a popular option. It can be retrofitted to a slurry tank under the TAMS grant. Your trade and shoe cannot be retrofitted under the TAMS. As regards the operation of the machine, your dribble bar is a far simpler machine to operate. As regards headland turning, lifting, dropping on your headlands, in terms if you were to reverse with your trading shoe here, okay, and you're going to do a substantial amount of damage compared to your dribble bar. For an operator that might be not as competent on machinery, a dribble bar is a much simpler option. This is a 7.5 meter dribble bar. As regards forward speed, that Francis covered in his app there, just to keep in mind, if you are looking at purchasing a low emission spreader and you're coming from a splash plate, your dribble bar system is going to be roughly, look, this is a 7.5 meter machine. You look, for instance, your forward speed at 3,000 gallons to the acre could be 5-6 kilometers an hour, which is a great increase coming from the splash plate. So your horsepower requirement is going to increase, especially if you're working on kind of a hilly ground or anything like that. You need to be sure that you're able to pull the tank full at that speed in field conditions. Also, on the requirements of the tractor there, there's going to be a bit more hydraulic demand compared to your splash plate. You have to run a macerator here. This is your chopper here. Okay, so all the slurry on both machines has to be put through your macerator. It chops the slurry, okay, chops the fibers in the slurry. I suppose in terms of your slurry, you're going to have to try keep farm objects and material to a minimum as regards plastic and maybe bits of timber, because they will block your macerator. We'll have a look at the maintenance of that in a couple of minutes there. Also with your tractor, this machine here, this dribble bar is working off of 2 hydraulic spools on your tractor. So just be wary that you may need more hydraulic outlets than you're using with your splash plate. We'll just move over to the trade and shoe here then for a minute. So as I said, your trade and shoe is parting the grass. It's probably the most preferred option in the Irish market, because you can enter, I suppose, a field that has that little bit more of a cover of grass on it and not contaminate as much grass. It's fitted again with a chopper. Okay, this tanker here is also fitted with an inlet chopper on the front of the machine. This is an optional extra that you can put on the tank at purchase. It will chop the material going into the tank. So this machine here is chopping the material, taking it in and putting it out, okay, to try avoid blockages in the pipes. Coming from a dribble bar to a trade and shoe, okay, there's a small little bit of a horsepower requirement increase again. As regards, this is a spring-loaded tip, okay, so this does need to be dragged through the ground. It does cause a little bit of drag on the tanker. So again, you will need a little bit more horsepower to actually pull this machine compared to the dribble bar, even though they're both 7.5 meters. This tanker here then is, as I said, the dribble bar was working off the spools of the tractor. This is just another variation here. This is tanker is fitted with an electro-hydraulic valve, which in turn uses one spool on the tractor, and then you use an electronic control box in the tractor to work all your different functions. So they're just two different examples. We'll just move over then quickly to the macerator here. So this is your outlet chopper fitted to the back of the machine. There would be a little bit of maintenance required on this. I would say at the end of every season, you would run a load of water through the tanker and put a lubricant between, okay, this is your knife and your cutting screen. You should place some lubricant in there, because if it's left, if the tanker's left sitting, they can kind of corrode to one another, and it can cause a little bit of damage then when you go to restart the machine after sitting for a couple of months. These knives here, okay, these do wear out, so these would need to be replaced. And the cutting screen, okay, this is this lad here. And then you have your preloaded springs here. They also would need to be changed. In terms, if your macerator has a lack of maintenance, you probably are going to get trouble with blockages and so on. So that's just one type of macerator here. Also then, just another example of another type of macerator here. This one here uses a gear type putting system compared to the rotary putting of the other one there. This is a gear type system with a cutting screen. Again, these do wear out and will need replacement after a period of time. So look, any questions, pop them in the Q&A and we'll get to them at the end.
That's great. Thanks, Patrick. I suppose just before we go away from you there, from an operator's point of view, somebody maybe moving from moving from a splash plate to a low emission maybe for the first time, like, is there a big difference, between the trail and shoe and we'll say the dribble bar from an operator's point of view, or would they be similar?
There would be a nice little difference in the sense, just like I said about the operator there. Your dribble bar doesn't require any lifting on the headland. You can just close the gate valve, turn around and open your gate valves again and continue spreading. The trailing shoe is going to require you to lift and maneuver the trailing shoe on each headland turn. Okay, a little bit slower, does take a little bit more time, but like when it comes down to an operator, if someone isn't as competent on machinery, the dribble bar is definitely a safer option. And also, I suppose, on your dribble bar here also, there's a break back function here that if you do, okay, get a little bit too close to something, there is a break back function here on the dribble bar that will allow it to spring back. This couldn't be fitted to a trailing shoe because obviously with the spring load of pressure and so on.
Yeah. And I suppose the other thing just for people to bear in mind is, I suppose there might be slightly higher power requirements too, whether between the two from a tractor point of view.
Yeah, like for instance, there both these machines are 7.5 meters. Like I said, the dribble bar has no ground contact, so it doesn't essentially put any drag on the tractor. There is a little bit more requirement on the hydraulics end of the tractor, okay, but as regards ground contact, the dribble bar doesn't touch the ground, so there isn't that increase in power requirement. But with your trailing shoe, because you have these spring-loaded tips in contact with the ground, they are causing a certain amount of drag and they are going to put a bit more of a pull on the tanker. Also, those tips there are a wearing part, so they would also need to be looked at. That's to bear in mind too when you are looking at a dribble bar trailing shoe. There's a lot less maintenance with your dribble bar because you don't have ground contact.
Yeah, and I suppose just the only other thing that people might get caught out with maybe is you mentioned there just about the electronic spool valve, but would say if somebody was going for a more basic version, just the actual number of spools might increase, wouldn't it? Yeah, so
like our dribble bar here is working off of 2 hydraulic spools on the tractor. That's the minimum requirement. It could possibly be 3, but we've had an electric diverter valve fitted to the back of the tanker, so we're able to change between, essentially when we're operating this machine here, when the machine is folded out in the field using the spool valve, we flick over a switch in the cab and that allows us to use that same spool to run the chopper on the back of the tank. So that minimizes your number of spools, because you would need 3 if you didn't have your electronic diverter valve.
Yeah. Just something for people to bear in mind, just to make sure the tractor is suitable for it. Thanks a million, Patrick. That's excellent, Raj College. We're going to move to Kendrick Hull. Kendrick is with Vantage Ireland, and I suppose Kendrick is actually going to take us through, well, maybe to another extreme altogether, and we're just going to start with a video that they have of a machine they recently sold their equipment onto. We'll start with that, and then we'll come back to Hendrik just to look at flow meters once we've watched that. So I'll just start that to play here first.
With this tanker, we've supplied the Isobus ECU, which does all your control. We have the distribution box, which is all your wire pinning to your valve block for your hydraulic control. And it also has the flow meter and a variable actuator to control the flow rates of the tanker. So with the ECU Isobus, then it's all programmable to several configurations depending on the build spec of the tanker. You can add in automatic sequencing for your spread. So with this particular tanker, it turns on the gate valve, then a couple of seconds later it turns on the macerator divider, and then it will drop your trailing shoe as it starts to spread and you drive off. All that's done through the controller that can be predetermined to the manufacturer's or the customer's requirements and can be altered as required. Also with the Isobus solution, we have the flow meter on the tanker. So the flow meter is there, which is recording the flow rate of the slurry. So in your screen, you can set your target rate. With the flow meter, it'll see what flow it is, and with the linear actuator, it closes off the gate valve to get your required flow from what you're doing. So with the Isobus tanker, like you're not limited to a certain speed. Like, you know, if you vary it at speed, vary your speed with the tractor, then the tanker will adjust it to suit. So again, on the back of the tanker, this tanker has the linkage. It also has your divider for your trailing shoe. Again, that's all controlled through the Isobus controller, which can all be done on timing. And with the divider as well, we can also change the direction each time it's started, or if it senses a blockage, it will automatically change direction to try and clear that blockage. So as you can see on this tanker, you know, there's quite a lot of hydraulic functionality. Without the Isobus control, you would have a lot of pipes to plug into the back of the tractor, but with the Isobus control, you know, you then only have your 2 pipes if it's open center or 3 pipes if it's load sensing. So again, can be done on the spec of the tanker. Again, the Isobus solution, like this tanker, it is skateboard ready. So basically, skateboard ready is the ability to add an NIR sensor. So with your NIR sensors, it monitors the nutrients passing by it. So it'll look at the NPK content. It then feeds all that back to the display, and you can also set it so you can regulate your slurry distribution based on your content rather than the volume. So that's all added functionality with the Isobus solution, and that gives you full traceability and helps make best use of the nutrients in the slurry. So.
Okay, that's great. Kendrick, I suppose that's a big step on from the simple little calculator that we've created that's based on, I suppose, the full load of slurry. You know, you've real-time control there of the actual flow. Can you tell us kind of what, I suppose that's the high end? You might take us through, I suppose, the full range of flow meters that you have available. I think you have a presentation there that just to kind of explain how they work and what's involved in it.
Yeah, good morning, everyone. Yeah, the video there does show the full solution offered by Muller for the Isobus solution, which gives full control. But with Vantage, we are starting to offer several other flow meters that can be easily retrofitted to tankers or umbilical systems. A more affordable solution there, sort of thing. So I just have a presentation here. 1 second. So I assume everyone can see that now.
Yeah, you can see that. Yeah.
So yeah, we offer, like, as well as the full Isobus solution, which has the variable rate control, has full hydraulic functionality within that. We do offer some standalone flow meter options. So there's kind of 3 options that we offer. One is kind of a standalone Isobus flow meter. So you put it into the back of the tanker or on your umbilical system. It'll connect via Isobus to your tractor screen. Just moving on, the Isobus one. And then for your Isobus screen, you know, it works on a similar principle. You know, you put in your applicator width, you put in your required target rate, and because it's reading the flow, it'll give you a recommended speed to drive to, sort of thing. Also, because it's, you know, it's an Isobus system, it's connecting in there. You know, if you run it through your GPS system with your task controller from your Isobus flow meters, you can then actually retrieve like an application map of where that slurry has been placed on your field. So that's another option that we offer. Another option is like a Bluetooth flow meter. Let's move down. So with the Bluetooth flow meter, then again, if your tractor isn't Isobus ready and you're just looking for a flow and a target speed, then we have this Bluetooth option. So again, you can kind of quite easily retrofit that. All you need for that is a power source to the flow meter, and then that'll come with a tablet where you get an app installed onto it, and through the app, again, set your target rate and your application width, and it'll give you a recommended speed to drive to. But within that little tablet as well, you can then enter like a job details. So you can give it a farm name, date, time started, time finished. You know, it'll tell you how long the job's taken or whatever, and you can save that details into a text file there, sort of thing as well. And you know, if you're a contractor or whatever, then you can actually put in a costing, and it'll give you the total cost of that job, which you can then save to a text file so you have it later for your record, shall we say. So with that one, like, it won't give you a coverage map, but you know, it'll show you the flow, give you your desired speed, and will record basic information of what that job was and what it is. And then again, if you're just wanting a basic flow meter, which is just a remote head, so with this flow meter, again, it just monitors the flow through the umbilical or the tanker, and it'll just give you an actual live flow rate, you know, readable in the cab there, sort of thing. You know, it will give like a total volume gone through the flow meter, but it won't give you a target speed or anything like that. It just literally gives you an actual flow. So, you know, with your tankers, it's easy enough to kind of, you know, use the app that Francis went through before to get your flow rate and your target speed. But if you're running half a tank, or if you're actually running an umbilical system, then again, this is where your flow meters start to come in. So these are the options that we can offer without going to the full Isobus option. That's kind of generally fitted with your manufacturer of the tankers. You know, again, they all can be retrofitted, but it's just a varying degree of what's required to fit them.
There's if you might go back up to just to where you can see through it, there's actually nothing inside it. There's nothing causing a restriction.
No,
how does it work?
Nothing inside them. It's done through inductance. So obviously, as the slurry is passing through that, it does generate a kind of electric field, and that's how it calculates the flow.
Yeah, so there isn't actually a moving part in there that's going to give trouble over time or anything like that.
There's no moving parts in there.
Yeah, yeah, or something that's going to get blocked up with dirt. There's different sizes I see there as well. Is there a different diameter? What kind of size would you recommend, or what kind of? Is there different sizes for different tankers or for?
Yeah, well, there's different sizes that we can offer. So we can do small. I think it's like 1.25 inch for water application if needed. But the two popular ones for slurry are the 4-inch and the 6-inch. So again, it just depends on the tanker that you're running and the pump size, the pump flow, shall we say. I'd say that kind of the more popular one seems to be the 4-inch at the minute, because even with the umbilical systems, like they'll start generally with a 5-inch pipe, but when they get to the the dribble bar or the applicator, then they're down at 4-inch. So obviously the 4 inches is slightly bit cheaper.
Yeah, and you're not restricted any more than the actual machine is anyway. So you're not going to cause a restriction in the flow by putting in there. Yeah, as long as it's at the end of the line.
Yeah, I mean, if it is a big tanker with a big pump on it, we have had some inquiries from a manufacturer that tankers going abroad with like a 24-meter kind of trailing shoe. They were looking at the 6-inch one. Yeah. Because it's a wide application sort of thing with a big pump on it, and it just needs that extra flow. But generally, the 4-inch one is more than adequate for most applications.
Yeah, I suppose just while we're on that kind of technology, I suppose maybe another thing worth mentioning maybe would be GPS and guidance and auto steer. The advantage of that when I suppose particularly using the low emission equipment.
Yeah, well, I mean, when you're using your low emission equipment, especially with the trailing shoes and your injectors, then it can become quite difficult to see where you've been, especially if you're going back to fill up, what have you. So that's where your GPS can come in. So your GPS, you can add a GTFS system to guide you where you have put the slurry already and where it's still to spread, sort of thing, And again, with a GPS, it can give you your total area spread and your total field sizes all calculated through. So, and additionally, if you are using that isobus flow meter with your GPS positioning, that's when you can get your application maps through the task controller. With the positioning data and the flow data, that's how you can create your maps with your office software as well, shall we say.
Just on that, I suppose the big difference between that one is you're actually able to control the flow rate by adjusting that infinitely adjustable lollipop. So you're actually controlling
I mean, there's two isobus options that we offer. So the one being the full Muller package, where you get the full isobus controller, you get the linear actuator, which adjusts the flow rates, the flow meter, and then you have also the additional functions that you can add in, your hydraulic functions. If you have a electro-hydraulic valve on there as well, you can add in all them functions and record sequences. So that's kind of the full isobus package that we can offer. But then we also offer just the kind of the standalone isobus flow meter, which just gives you a flow rate and a target speed. You don't get the linear actuator with that one. It's just basically a flow meter there. So there we go.
Are the flow meters expensive? Are they a big cost to add on to? Say, I'm particularly thinking, the umbilical systems would be a big advantage, where they're.
Yeah. Well, I mean, them standalone ones that we can offer, you're somewhere between 1,700 and 3,000.
Okay.
And depending on the option, and then obviously for the full isobus installation with the hydraulic control block and the linear actuator, then prices go up.
Yeah.
Depending on spec, shall we say?
Yeah. Excellent. Yeah. Thanks a million, Kendrick.
No problem.
Appreciate that. Yeah. Right, got it. Next, we're going to go to, I suppose, a real expert. We're going to go to Richie White, contractor, I suppose, who's knows more about Slurry than any of us put together. So, Richie, you might introduce yourself first and maybe just tell us a little bit about the business.
Okay. How are you, Francis? We run a business called Silvermine Agricultural Services Limited. It's 26 years old. We've been contracting our family has been involved in contracting for 50 years, I suppose, to be honest about it. So we're involved in slurry handling, forage harvesting, and all tillage operations. So it's a comprehensive service to all the farmers in the locality and in our parishes.
Yeah.
I suppose we're at Slurry for 35 years, I suppose, to be honest about it. So it's that's what we're about.
Yeah. And what type of slurry equipment are you running now, Richie, or what's?
So at the moment we use Teagasc trail and shoe systems. We've been using them since 07, to be honest. We use two umbilical systems that are the dribble bar systems, basically. One Slurry Cat system and the other one is a grip system from James O'Kane.
Yeah.
All systems work quite well, to be honest, but it's all down to the material going into them, to be honest with you, at the end of the day.
Yeah.
So I suppose the problems we find there, I suppose, through the history of the whole trail and shoe systems is the slurry itself needs to be clinically clean, to be honest about it. What I mean by that is debris is a bit of a problem, say, like some netting and plastic and bits of pallets, and like it has to be clinically clean. People call these things here macerators, but to be honest with you, they're distributors, and they're only distributing the slurry out through them pipes, basically. So the slurry has to be like soup, to be honest with you, for it to work properly. There is some illusions there that you can put anything through these things, but you can't, to be honest with you. And you know yourself, it's like anything.
And what advice could you give farmers? You said a lot of farmers now might be having, maybe getting into low emission themselves, or have contractors coming in with low emission equipment for the first time. How can they ensure that the slurry is suitable?
Number one is to minimise any debris getting into the slurry. The slurry needs to be clean. What I mean by that now is, as I said earlier, like plastic and bits of pallets, all these kind of things, bits of odds, wire, all sorts of queer things. We've seen it all, to be honest with you. They're the problems, and these machines are not made for this kind of thing. You'll get away in the past with the old splash plate system, you'll get away, with all that kind of thing, but not with these type of systems. This system is not catered for that kind of thing. That's what we've seen,
For a contractor or a farmer who's thinking of going into low emission, this season, what challenges or what advice would you be giving them as regards to machine setup and that?
Well, number one, agitating what we find is the slurry needs to be really right, so it has to be agitated really well for these to work extremely well. You know what I mean? Also, I suppose we have to talk about safety. Really, the season is starting off now as of today, and we need to talk about safety. We've talked about the slurry gas is an issue. It's a major it's a major concern, to be honest with you, for both all of us, to be honest with you, involved. Also PTOs, all these things are all. Another thing I noticed as well is the cleanliness on the farm yards. This might sound a bit mad, but it's very important that the yards, wherever the tankers or the tractors that are, based in the yard are going in out for to load the slurry, that the yard is actually clean, to be honest with you. This is a problem I've seen down through the years, and that there's some method that the yard can be washed or cleaned, and that for slippage, for people in and out of tractors and things like that, that the area is clean. And also, another thing is the manholes. I've seen this is a major problem down through the years, where after a few years, the manholes, I find that they're always broken. Not everywhere, obviously, but there's a bit of maintenance I think that people should be looking at, to be honest. And their concerns as an employer with your staff and everything, that when they're going into a farm, that safety is paramount, to be honest with you.
Yeah. So everything is right. Yeah,
exactly. Yeah, yourself, a bit of common sense about everything, to be honest with you. It's all common sense at the end of the day. But they're the problems we all see, you know what I mean, and we hear from from everybody, So that's the general run of it,
Yeah. On the umbilical system, what I suppose what are the pros and I suppose the limitations, with running those?
Well, sure, the umbilical system basically is going to work where a tanker, if the ground conditions are just a bit too heavy for the tankers, the the umbilical will work quite well, to be honest with you, but you're limited to the distance you can pump it, you know. So it's all relative to what you want to do on a farm, like, to be honest with you. You know? It's a very, very good system. It works extremely well, you know. But it's then the slurry again has to be in good condition, to be honest with you. It can work through that can be pumped, and it can, it has to be exactly the same as the trail and shoe, or the trail and shoe system. It's all relative.
And what about crossing roads and things like that? Is that possible? Or is there ways around, or safe ways of doing that?
Crossing roads is a nightmare. No one wants to be crossing roads with pipes, to be honest with you. Like from an insurance point of view, and every point from the public's point of view, you just don't want to be doing that type of thing. You try and minimise that if you can. So the ideal way of doing that, if you can, is to bring your pipes underground, basically, or if farms are setting up new roadways, or they're doing that, pipes can be brought across the road, basically, that are permanent, that you can join into them and plug into the pipe and then work from that. Like, that's if there's anyone putting in new roadways or stuff like that, they should be talking to the contractor and thinking about all this before they ever do anything. It's a bit of common sense, like. But we as contractors really don't want to be crossing public roads with pipes, because you're only looking for trouble, to be honest with you.
Yeah. But there is ways to save of putting
yes, of course,
permanent pipes underground if you could. Yeah,
exactly. Yeah, or if you can just work it in a different way.
Yeah.
So that'd be about the run of it, you know.
Yeah, no, that's great, Richie. Thanks a million for joining us. To see we're running kind of tight of time now. We might go to the Q&A session there, so I might leave it back to you, Mark, there, maybe just to kick that off for us. So,
there's a lot of questions coming in here, both on slurry and equipment, but look, I'll kick off with one here, Francis. What is the increased cost per acre, hour, or per hour charged by a contractor when using less system rather than a splash plate? Maybe Francis, you take that one.
Sorry, Mark, I was reading another one. Go again. Sorry, the increased cost per hour.
Yeah, the cost between less and splash plate. What's the increased cost?
I don't know, Richard. Do you charge more or less, or would you have a similar? You're on mute there. Let's see.
If you're talking probably about a 20% extra, because the cost of running trail and shoes or dribble bars is far more excessive than the ordinary splash plate. Like, you're far more wear, it's a different business. So there is an additional charge. Of course there is. Yeah, there has to be.
Yeah.
Okay. There's another one there, Richie. Maybe I'll point it your direction. Are there issues with striping in silage fields from the dribble bar or trailing shoe system, and resulting in possible silage contamination in pits?
Yeah, so you can see, down through history, you can see it, mainly because the slurry is too thick, to be honest with you, and there's the uptake. The grass didn't seem to be able to take up the uptake of the grass, because just the slurry is just too thick. So if the slurry is thinner, it'll run. It's not inclined to stripe as much.
Okay, so dilution and maybe the weather conditions.
Dilution is everything at this job, to be honest.
Yeah, and maybe weather conditions thereafter, Richie, would be a help too.
Oh, absolutely, it's all down to the conditions. Every day is different.
Okay. There's another one there as well, Francis. Is there a height that the pipes of dribble bars should run along the ground when spreading? Maybe that's for an umbilical system, is it? Is there the height of the dribble bar? The
dribble bar. Well, look, I suppose no, there's not. The dribble bar is close as possible to the ground. I suppose the higher up it's going to be, the more contamination you're going to get with it. So I suppose as low as possible. That you can get rid of. Now, there is variations even on, would say, trail and shoes. What I would say is that, what's classed as a trail and shoe here may not necessarily be classed as a trail and shoe on the continent. There's a minimum downforce required on the continent for a trail and shoe, whereas here, literally dragging along the top of the ground is actually could be deemed as a trail and shoe.
Okay. A question here from Tim Gleason. Can independent macerators be purchased that would shred on filling, and that would obviate the need for such on the tanker while spreading? So sort of an independent macerator, Francis.
There is a macerator, Patrick mentioned it, would say, on the tank there in Kildalton, an inlet macerator is what it's called. So it's a macerator, so you're actually chopping the slurry as it's actually going into the slurry tank. And then there's a second macerator distributor on the back of the machine where it's going out, so it's kind of getting a double chop. Look, you're obviously adding an extra load on the machine there, it does tend to push down that outlet a little bit lower as well. So there's just things to bear in mind. But look, they are available. Now they do need to be maintained. I do know that we had problems in Kildalton at one stage where the tank was taking an awful long time to fill, and it actually turned out that that inlet macerator, one of the plates had actually come slightly apart, so it was actually causing a restriction on the way in, like, you know. So they are available. They wouldn't be hugely popular, but we do happen to have it on the one in Kildalton.
Okay. Another question here as well. Any idea what would it be? What would the cost of buying a dribble bar or a trailing shoe?
I don't have costs. I didn't look up costs at the minute now. Look, there is, I suppose the one thing that we didn't mention yet, I suppose, is just the grant aid that is available. You know, there is a grant aid available, of up to 60% for both types of systems. Now, just to bear in mind, there's a grant aid available to retrofit a dribble bar, so you can actually retrofit a dribble bar onto your existing tank. So that way you could keep cost down quite considerably, because you're only buying the actual dribble bar unit to go on the back of the tank. Now you can't retrofit a trail and shoe onto a tank and get a grant on it, you know, because in fairness, the department, the way they're looking at it is that, you know, the whole tank has to be designed to take a trail and shoe, because you're putting that extra force down. You know, you're transferring some of the weight of the tanker onto it. It has to be designed for it. So if you were going with looking for a grant for a trail and shoe unit, you actually have to buy the tank and the trail and shoe as one unit. You know?
Okay.
Now you can trade in your existing tank, you know, against that as well, and use it as part payment, like, you know.
Okay. Conscious of the time, a few quick ones here. I can take this one. Is the dribble bar system as efficient as the trailing shoe? There is a slight benefit over the dribble bar with the trailing shoe, as you're getting the Slurry very close to the ground. You're only talking about a unit per 1,000 gallons, but on a good day for nitrogen recovery, is probably very, very little difference. There's a question here as well, Francis. How much Slurry should I spread per acre? I can take that one. Like, I think it very much, what's the nutrient demand? Like, say if you're spreading, say, in the early part of the season, say in February, you know, where you're delivering maybe 10, 15, 20 kilograms of nitrogen, you're talking somewhere around maybe 1,500, 2,000 gallons per acre. There's another question here as well, Francis. With the current price of fertilizer for the first round in February, should I apply 23 units of nitrogen in protected urea or 2,500 gallons of Slurry per acre? I would very much say, my I suppose other question there would be, you know, what's the P and K requirements? You know, if you're putting on the field that has a P and K requirement, most definitely use the Slurry. But if you have ground that doesn't need P and K, the alternative in protected urea is probably the better option. So that's more getting the value out of the Slurry. Okay.
There's one there about I see, you know, should contractors get the grant too? Look, I think there's a good argument for that. Like, Joe, that Joe, in fairness, you know, a lot of this equipment, even like we see where Kendrick is going with that high-end technology, where we can, you know, put the right rate, particularly, you know, trying to calibrate the likes of the umbilical systems. You know, it is a specialized job, like, Joe, and they are the experts, like, you know. So it is. You know, it is something, you know, you would like to see that they would be able to get a grant aid on it.
Okay. There's a lot of questions around where can you get Slurry tested, where you can get hydrometers. We'll make that available, Francis, after the seminar here this morning. There's also a question there on, would you have figures on the value of pig Slurry? Yes, we would. Pig Slurry is something like a 19,720. 19 units of nitrogen, 7 units of P, and 20 units of potassium.
We might take the pages from the book, the green book, and maybe put them up. Will be where we're going to put up. We'll send the details of the taste up on the public website.
We can do that.
Yeah.
Are you happy enough, Francis?
I am. I'm conscious of time now, and what you call it, I'm keen that we wrap it up on time. I just wanted to say thanks a million for everybody for contributing today to make this possible. So for all our speakers, I just wanted to thank the people in the background that made it possible. Claire, in fairness, who's been helping out the last couple of days to get us and been doing the video work there for us. Also the the team in Teagasc who I suppose helped us get it set up and publicity and everything around it originally. Just the team in Kildalton, in fairness, they've put in a lot of effort there to get the equipment and everything set up there. So I just want to say thanks very much. And look, as I say, thanks a million for joining us all today. As I say, we will put up a page on the public website with all the information there, and we'll try and answer as many of those questions as possible on that page as well. So right, so we'll wrap it up and leave it there.
Thank you.
Thank you very much, everyone.
Bye now.